Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the third lesson on geometric sequences, looking at sigma notation, and this is a significantly more complicated example. So here we have evaluate, again work out the sum, sigma the sum, n equals 2 to 9, and then this here is the rule for the sequence 0.9 to the power of n plus 0.9n plus 4. Now in the previous video I talked about writing out the first few terms of the sequence to see how it's behaving. This is going to be a problem here, and the reason for that is that the series that we're summing is formed of two parts, one of which is a geometric series and the other of which is arithmetic. How do I know that? Well, this bit is to the power of n, so this is a geometric sequence here, whereas this bit is arithmetic, 0.9n plus 4, so it's like an nth term rule, like the kind of thing you would have done in GCSE. It's a linear sequence. So what I'm actually going to do is I'm going to treat it as two separate series and sum them together at the end. So the first thing I'm going to do is I'm going to do the sum n equals 2 to 9 of 0.9 to the power of n. Now, something to be careful of here, we're starting with n equals 2, which means that the first term of this sequence is not going to be 0.9 to the power of 1, it's actually going to be 0.9 squared, 0.9 to the power of 2, which is actually 0.81. The next term is going to be 0.9 cubed, which is 0.729. Now that is enough information for me to work out that A, the first term, is 0.81, and that R, the common ratio, is 0.9. Now we've just got to be a little bit careful here, because we're going from 2 to 9. So how many terms are there in this sequence? There's not 9, because we're not starting at 1, we're starting at 2. So actually this sequence here, crucially, has only 8 terms. So when I crack out my formula, sum to n equals a times by 1 minus r to the n over 1 minus r, I'm doing sum to 8 terms. A is 0.81, 1 minus 0.9 to the power of 8, all over 1 minus 0.9. I'm just going to work that out on my calculator here. So 1 minus 0.9 to the power of 8, multiply that by 0.81, and divide it by 0.1 is going to be 4.613215599, and I'm going to store that as a value in my calculator so I can use it later on. The second bit that I'm going to look at is I'm going to look at this sum of 0.9n plus 4, again from n equals 2 to 9. Now the first term of this sequence, when n equals 2, is actually going to be 0.9 times by 2 plus 4, so 1.8 plus 4, which is 5.8. The next term in the sequence is going to be 0.9 times by 3 plus 4, which is 6.7. Now this is an arithmetic sequence, not a geometric sequence. So A is still the first term, which is 5.8. But instead of a common ratio, we have a common difference, which is what the sequence is going up in, which is 0.9. And just like with the previous one, we have 8 terms, the logic being the same as with the previous one. If I start on 2 and go to 9, that's not 9 terms, that's only 8 terms. Now again, because this is an arithmetic sequence, I'm going to be using the sum to n is n over 2, 2a plus n minus 1d, which is the rule for an arithmetic sequence. So the sum to 8 would be 8 over 2 times by 2 lots of 5.8 plus 7 lots of 0.9, and that 7 has come from n minus 1, 8 terms, therefore that number's 7. So I'll just work that out on my calculator. So 6 plus 6.3, multiply that by 4. We get a slightly nicer answer, which is 71.6. So my overall sum then to evaluate n equals 2 to 9 of 0.9 to the n plus 0.9 n plus 4 is going to be the sum of the geometric bit, which is this value here, so 4.6132, etc., plus the sum of the arithmetic bit, which is 71.6. So I'm just going to add the stored value from my calculator to there, and to 3 significant figures, that is 76.2. So a tough example, that tough problem to work through. The key thing you had to realise was that there were 2 parts to this series, a geometric part and an arithmetic part, and there isn't a rule for summing a combination of the 2, so we had to treat it separately as a geometric part and an arithmetic part, and then work out the total at the end. Something just to watch out for, it's sneaky but they do it, n equals 2. Okay. Normally, majority of the time, you start on 1. You're saying we're starting in the first position. Sometimes you start somewhere else and you've just got to be aware of it, and in this context it's a case of thinking, how many terms am I going to end up with in my sequence, depending on where I've started to where I'm going. Job done.